for this problem, I want to consider two lines. L1, I want it to be the line containing the origin in the point 2, 0, negative 1. And L2 be the line containing 1, negative 1, and 4, 1, 3. And I want to find the distance between L1 and L2. Great, and so what's the idea here? And first of all, I want to see that if these two lines intersect. If these two lines intersect, then my distance is automatically just 0. And notice that I can first solve for the direction vectors of L1 and L2. So I can write L1 as V1 plus some t times 2, 0, negative 1 minus 0, 0, 0, because it passes through these 2 points. And this is just V1 plus t times 2, 0, negative 1. And L2 is V2, some V2. I don't know yet what V1 and V2 is, but I do know that these two lines must be of these form. Is V2 plus t times 4, 1, 3 minus 1, negative 1, 1. And this is just V2 plus t times 3, 2, 2. So we notice that these two direction vectors are independent, which means these are not multiples of each other. And whenever we have two lines with independent direction vectors, there exist two planes. P1 containing L1 and P2 containing L2 such that P1, P2 are parallel. Why? It's because if my two direction vectors are independent, then the cross product between them is non-zero. So I can find a unique direction that is perpendicular to them both, right? So n equals uh, 3, 2, 2 cross 2, 0, negative 1 equals negative 2, 7, negative 4 is the normal, well, is the common normal of P1 and P2. Right. So now we know that P1 looks like all the vectors V in R3 such that V dot my normal n equals some constant C1. And my P2 looks like all the V's in R3 such that V dot negative 2, 7, 4 is some constant C2. I want to see if these are the same planes. If these are the same planes, then L1 and L2 intersect, and then their distance is 0. So I just need to see that if C1 and C2 are the same. So notice that 0, 0, 0 is in L1, and P1 contains L1. So the origin is also contained in P1. And since the origin is in P1, it must satisfy 0 0, 0 dot my normal equals C1. So C1 is 0, 0 dot -2, 7, -4 is going to be 0. So C1 is 0. And I just need to find a second point on L2. Let's just take 1, -1, 1. This is in L2. And so 1, -1, 1 is in P2 because P2 contains L2. So C2 is just 1, -1, 1 dot -2, 7, -4. And this is -13. And therefore, P2 is not P1. And recall that for parallel planes, if they're not the same plane, then they are then they do not intersect each other, right? So the distance between P1 and P2 is not 0, so the distance between L1 and L2 is non-zero. Great. So this is right now the picture we have. We have some L1 and L2, two lines in our space, and I want to find their distance. Excuse me. But I know there is a direction that is perpendicular to them both, right? And this direction is just my normal vector of the planes. So if I can find some x1 in L1 and some x2 in L2, I connect them, form the right triangle, and then my h here is just the distance I'm looking for. So how to find h is just going to be the projection, or the size of the projection, of x1 minus x2 onto my normal n. So again, I can pick my x1 to be 0, to be the origin, x2 to be 1, -1, 1. Then I get that the distance between L1 and L2 is equal to h is equal to the size of, we plug in the projection formula, so x1 minus x2 is just going to be -1, 1, -1 dot my normal -2 and -2, 7, -4 over the norm of -2, 7, -4. And this should give us 13 over square root 69. And that's our answer.